Hello students, welcome to session number 35 of unit 5. This unit is amplifier and oscillators. So this session or this unit consists of 12 hours. Among 12 hours, we have covered 2 hours, that is 33, session number 33 and session number 34. So in session number 33, we already studied the definition of amplifier, faithful amplification and classification of the amplifier. So the classification of the amplifier based on configuration and power handling capacity. So and type of connection or the output. So in that the one point, that is classification based on power and handling capacity, the amplifiers are classified as class A, class B, class C and class AB. So in this session we have working of class A amplifier, class B amplifier and class C amplifier. So this power handling capacity means these amplifiers has to have larger power. To have the larger power carrying capacity, the construction of the power amplifier is different than voltage amplifiers. So the voltage amplifier carries the high voltage but less current, but the power amplifier carries the more power or high power. So constructionally, the voltage amplifier carries the high voltage. To carry the high voltage and the low current, the voltage amplifier differs in construction that the base material or the base section is thinner, that is beta is larger, that is current amplification beta is larger. Coming to the power amplifier, the construction of the power amplifier in such a fashion that the power amplifier construction base material or the base section is larger to carry the high current with the voltage. So to carry the high current means the base section should be very much larger, and as usual the beta is smaller. So this is the constructionally difference between the voltage amplifier and the current amplifier. So now what is class A amplifier, what is class B amplifier, what is class C amplifier? Of course, we'll cover the working also. Briefly, what is class A amplifier? So the class A amplifier amplifies the whole signal, that is 0 to 360 degree of input cycle is amplified with the 0 to 360 degree at the output without changing any physical shape. So those amplifiers are known as the class A amplifiers. In class B amplifier, only one half of the cycle is amplified, means the only 180 degree, during the 180 degree the collector current flows, and hence these class B amplifiers are amplified only positive half cycle or maybe negative half cycle. In class C amplifier, collector current flows for less than half a cycle. So less than half a cycle means greater than 90 degree, less than 180 degrees. So the input is, even though the input is full cycle, that is 0 to 360 degree, the output is only between 0 to 90 degree, a little bit more than the 90 degree. So that is known as the class C amplifier. So these amplifiers are single stage amplifiers. So single stage amplifier, with the single stage amplifier, so the amplification is not sufficient. Then we'll go for a combination, that is multi-stage amplifier. The combination of ABC is connected in a coupling using coupling capacitor or a coupling transformer. So those are known as a multi-stage amplifiers. So in multi-stage amplifier, class AB amplifier is also called as push-pull. Of course, we'll study it in a next session. So this class AB amplifier amplifies the input signal with the more than 360 degrees. So less than more than the 360 degrees means 1.5 cycle, or more than the 360 degree it will amplify. So now let us start with the class A amplifier. So class A amplifier, the constructionally similar to the what we have studied in the session number 34. So 34 covers the CE amplifier with the biasing. So here biasing is provided R1 and R2. So provided by the potential divider resistances R1 and R2. As usual, the stabilizing resistance RE and load resistance RC, that is a collector resistance. And capacitors, of course, C1 and CE are connected. C1 is the allowing the bypassing the DC and allowing the only AC, and CE is a stabilizing. Okay, so now the constructionally, so these capacitor and the working of class A amplifier, the power amplifier is biased in such a way that the transistor should remain in the active region for all the input values. So the operating point Q is selected in a such a fashion that so it always be midpoint of the load line. See here we have come across a special point, that is special definition, that is Q point or point Q point. So what is this point Q? So this is point Q stands for quiescent. So what is this quiescent? That point quiescent, or it can also be called as operating point or the silent. The transistor when it keeps silent, so that point is at where the transistor is silent, that point is known as a silent point, or it cannot be also be called as quiescent point or the operating point. So this will happen when the zero signal values of IC and VCE, so where the point which meets the load line, that load line is zero signal values of IC and VCE. So as usual, the load line represents the three situations or the three regions of the transistor amplifier. So that three regions are cutoff, saturation, and in between these two, that is the operating region. So in between the cutoff and the saturation region, so where the point is exactly middle or the any point somewhere else is known as a Q point. That point represents the silence of the transistor, means transistor is exactly silent, it's not working. So that point is known as a quiescent point. That quiescent point is also called as operating point or the silent point or simply Q point. Okay, so this operating point for a class A amplifier is selected exactly midpoint of the load line. So midpoint of the load line means active region. So keeping away the saturation point, saturation region and cutoff region. So in between these two, there is a large area, that is active region. In active region, midpoint na select ಮಾಡ್ಕೊಂಡ್ರೆ, that point is called as a quiescent point or Q point or the operating point. So in class A amplifier, so this is exactly midpoint. So where the transistor is off, it's not cut off, it's off, it is silent. I can say this is silent. Now the collector current IC flows for both the positive and negative half cycle of the supply. Means the collector current, because the biasing resistance are there, these biasing resistance supply the base current continuously for a with the input signal, and hence IC flows for the collector current flows to the collector through the collector for a positive as well as the negative cycle. Now the position of the Q point is approximately midpoint of the load line. So now next, the output wave shape exactly similar to the input shape. Only thing is it is amplified. So little bit distortion there. So we can because of the biasing resistances. And biasing resistance include ಮಾಡಿರೋದ್ರಿಂದ ಡ್ರಾಬ್ಯಾಕ್ ಏನು ಅಂತಂದರೆ ಪವರ್ ಲಾಸು ಜಾಸ್ತಿ ಆಗ್ತಿರುತ್ತೆ. ಆ್ಯಂಡ್ ಪವರ್ ಲಾಸ್ ಜಾಸ್ತಿ ಆಗ್ತಿರುತ್ತೆ ಅಂತಂದರೆ ಎಫಿಷಿಯನ್ಸಿ ಈಸ್ ನ್ಯಾಚುರಲಿ ಡಿಕ್ರೀಸ್. ಸೊ ದ ಎಫಿಷಿಯನ್ಸಿ ಈಸ್ ಅಬೌಟ್ 35%. ಸೊ ದಿಸ್ ಈಸ್ ದ ಡ್ರಾಬ್ಯಾಕ್ ಆಫ್ ದ ಪವರ್ ಎ class A amplifiers. So this class A amplifier without the input waveform and the output waveform is shown in the previous figure. So the input waveform is swing of the AC load line is drawn. The AC load line Q is selected. So the Q point is exactly between the center point of the active region, and input signal and the output signal are also shown. So load line is drawn. So this is already studied in the previous sessions and previous units. So load line is a line which drawn between the VCE and IC, VCE on x-axis and IC on y-axis. Coming to the class B amplifier. So class B amplifier, as already studied, so class B amplifier amplifies only half of the input signal. So this half of the input signal is amplified at the collector. So this collector, the same circuit is taken here, and because only half of the cycle has to be amplified at the collector, the biasing resistances are not required. So biasing is not given. These resistance can be excluded because same circuit is carried over here. So we can neglect the R1 and R2 since the biasing resistances are not required. So in class B amplifier, working of class B amplifier, the Q point and the input signal are selected such that the output signal is obtained only for a half cycle for the input cycle. The Q point is almost x-axis, almost on the x-axis. In class A amplifier, it is between the midpoint of the active region, but in class B amplifier, it is shifted to the x-axis. So Q point is in the x-axis. So due to the selection of Q point on the x-axis, the transistor remains in the active region only for the positive half cycle of the input signal. So during the negative half cycle, the transistor is cut off. During the negative half cycle, the transistor operates in a negative cut-off region and no signal is produced at the output. So we'll have the waveforms here, class B amplifier. So as usual, the load line is drawn and the load line represents the operating regions. So in that operating region, the Q point is already selected in such a fashion. See, selection of Q point is in an operator hand. So construction. So now the Q point is shifted to the x-axis means, so operating region itself is, the complete first quadrant the transistor is operating. So operating because the positive half cycle is sufficient to bias the input circuit. So and hence the emitter base junction is forward biased and there is no signal to forward bias the input signal during the negative half cycle, and hence the negative half cycle, during the negative half cycle of the input cycle, the transistor is kept silent and hence operating point is shifted to the exactly a Q operating point or the Q point. So Q point is shifted to the x-axis. The output waveform and the input waveforms are shown separately with the load line and without the load line also. So without the load line, that is waveforms are input cycle, that is full more than 180 degree, that is 3 pi input waveforms are shown, and during the positive half cycle only output is only positive half cycle is amplified, and once again another half cycle of positive half cycle is amplified, and it is the current waveform is means the current flowing through the collector is known as IC waveform is shown, and the voltage across the collector to emitter is shown. So it is exactly out of phase by 180 degrees with the input cycle. The amplified output voltage, that is VCE, the voltage across the VCE, that is collector to emitter voltage, is out of phase by 180 degree. It is also shown in the waveform. So this is about the class B amplifier. So coming to the class C amplifier. So the same circuit is carried over here. So here the working of class C amplifier. So here the operating point is selected in such a fashion that, so the Q point is in a negative direction, means the operating point is shifted to the fourth quadrant means before the positive half cycle, some negative voltage is applied between the input circuit. So negative signals are applied here, and the operating point is shifted. So the amplifier is given some negative bias so that the output signal is obtained for less than 1/2 cycle for a full input cycle. The operating point is shifted. So that is below the x-axis, you can say the fourth quadrant. So transistor is active for less than half cycle of the input, and hence collector current flows for less than 180 degrees. So coming to the waveform of class C amplifier. So now look at the waveform. So the waveform, the input signal, that is full 1.5 cycle input signal is shown, and the collector current, the output is, the collector current means output current. So the output current, so that is dotted line, or we can show that the hatched line. So the hatched waveform, so that is the amount of amplified output current at the collector side. So that is the amount of current flowing through the collector. So the dotted line is not amplified, and only the portion of the signal, portion of the half cycle, and the remaining portion of the half cycle is not amplified. So little bit portion of the amplified output is shown, and so the same signal is inverted at the collector to emitter voltage, across the collector to emitter voltage. So these are the classification and working of the class A, class B amplifier. So in class C amplifier, severe distortion because the biasing resistance are there, and the same thing, the operating point is shifted to the fourth quadrant, or so the signal is not properly amplified. So but of course higher power output and collector efficiency is higher than the class B. So in class A, lower efficiency and lower amplification, that is about 35% of efficiency. In class B, so 65% of efficiency, and class C more than 65% of efficiency. These are used for tuning amplifiers. Tune ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಈ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So now summarizing all these points, so that is class A, class B, class C amplifiers. So the same circuit is carried over. If you want, you can eliminate the biasing resistances for class B amplifier and class C amplifier, but class A amplifier is having the same circuit, that is biasing resistances are must, and class B amplifier, the biasing resistance can be eliminated. So no additional biasing is required by the class B and class C amplifiers. So this is working of class A and class B, class C amplifiers. So I hope all of you understand. Thank you.